Hi, everybody. Thanks for having us today. I want to thank Ken and the rest of the team that put the conference on. It's been a while since I did any public speaking, so hopefully I remember how to do that, I guess. If there's any awkwardness, you can blame it on my rustiness. But I wanted to introduce today two folks that I've been working with pretty closely. Peter Holt. Peter is a watershed planner with the City of Redmond. He's got over 20 years of experience working on stormwater management, habitat restoration, and regional salmon conservation initiatives. And I also work very closely with Matt McNair. Matt is also at King County, and he's a licensed professional engineer. He's dedicated to balancing the needs of the built and natural environment with a focus on transportation and stormwater infrastructure. He has a strong background in intelligent transportation systems, having started his career at WashDOT's Traffic Management Center in Shoreline, so the data and decision-making hub for real-time traffic control in WashDOT's Northwest region. And in his current role as the Water Quality Capital Program Manager for King County Stormwater Services Section, he's enthusiastic to support multi-agency pilot of smart stormwater in Bear Creek. These are investments in smart stormwater, enable stormwater managers to maximize infrastructure performance in real time, allowing adaptive management of dynamic stormwater challenges such as flooding and water quality, which are being exacerbated by climate change. I heard a number of themes in the last panel that I want to highlight. So as both Matt and Peter are talking through some of the questions I have for them, the relationship with operations and maintenance staff, I want to reemphasize that. I want to reemphasize the value of partnerships throughout the entire project phase, and then building in opportunities for multiple benefits like climate resilience and stormwater management. So we're excited about the opportunity to share our experiences with continuous monitoring and adaptive control retrofits of existing stormwater infrastructure. We call this CMAC for short. The retrofits themselves include sensors, actuated valves, a cloud-based operations platform that uses weather forecasting to predictively manage water. And this unlocks new opportunities to improve stormwater management and build climate resilient communities. So with that introduction and the introduction of the folks on the panel here and the concept, I'm going to ask the first question. I think maybe I'll ask Peter first. And I'm curious to know a little bit more about why Redmond considered CMAC as an option for stormwater management.
Hi, thank you for having me. City of Redmond has a watershed management plan that divides the city into about 20 watersheds. One of those watersheds, most of those watersheds are really built out conditions. They've already reached the maximum amount of density we're going to get given our current zoning configuration. So we're going in these watersheds, we're looking at them. One of the things we find is that the altered hydrology of these watersheds is causing problems for the streams, and probably the thing that we need to address most if we want to have an environmental lift. So when I go into these areas, I look at them, and the first thing I think about is the fact that I'm in Microsoft land and property values are very expensive. And then I look in these places, and I also see that these are built-out neighborhoods. Most of these neighborhoods were built with older facilities that are not built to current standards that are more protective of the environment with detaining the water for a longer period of time, or detaining more water, and keeping it from scouring out the streams. So question is, how do we do that? Well, we can build more facilities, but there's no land to build on because we're in built-out conditions, and it'd be very expensive. We can try to make the facilities bigger, but unfortunately, trying to make the facilities bigger means that we'd have to probably try to buy up some houses or condemn some houses, and that's not going to really happen and is not a politically viable solution. So we have to work in the same footprint that a limited footprint, the footprint that we're given in these existing facilities. And so with that in mind, that was one of the major considerations. I was looking for different technologies that would kind of do that. First thought was, we'll try a low impact development. Well, unfortunately, in this particular watershed that I'm working in, where we're using this CMAC, we have really bad soils, so we're not going to be able to infiltrate water using low impact development. So we thought, well, maybe we'll go deeper. We looked at deep well infiltration, and we found out that although we have outwash, it's saturated, and we couldn't get water into that outwash down low. So we're not going to be able to pump the water down into a lower place. So we need to find another means, and this solution came up as a potential solution. But there's some other reasons I liked it too. I liked it because it's adaptively managed, meaning that if we try something and we're not getting the results we want, we can we have a way to try to make these things work a little bit better. So essentially, the answer to the question, to summarize, is given the conditions on the land, we are in a very tight quarters. We had to find something that would work in the footprint that we really wanted to try. We didn't have a lot of tools, and the tools that we were looked at weren't working. And then 3, wanted something that would allow me to test it, adapt, change my pathway, and just give me more control over doing something, so that I would be able to dial the needle and get to the conditions and the results I wanted.
Thanks, Peter. Yeah, Matt, how about you? You want to talk a little bit about why King County considered CMAQ?
Checking.
Yeah,
Okay,
there you go.
on. Yeah, but I'd like to back up a little bit and first talk about why we're focusing on Bear Creek, because I think the geography really defines some of our solutions and even our partnerships. But Bear Creek is one of the last best places in King County for salmon habitat and survival and spawning. And there's a big focus on us trying to improve water quality for salmon survival and for community and public health. And that need is actually codified in our regulation and planning too. So another theme of a lot of the things that preceded this panel is the amount of planning that goes into any capital project or delivery. And I'm lucky to be in capital trying to deliver projects, but we stand on the shoulders of giants that have done a lot of work to get us lined up for success. And one of those is our permit compliance. We have an NPDES permit, and part of that permit compliance is a Stormwater Management Action Plan, a SMAP, that we are required to work at the watershed level across jurisdictions. So that's what really helped me get to know Peter professionally and develop a relationship and a network that made this project possible. The SMAP also requires us to do both short-term and long-term capital projects. So we had to get some projects in the ground as early as 2028, which when we have to encounter some headaches like permitting or acquisitions or working with the public, that can really put a delay on your schedule. So CMAQ looked like a really opportunity to do a low-cost, quick solution to work within our existing infrastructure and maximize the performance of that existing infrastructure through a pilot.
Thanks, Matt. You know, I'm glad you mentioned the partnership with Redmond, because for my minimal amount of involvement in the project, I recognize how important it was that Redmond went first with implementing CMAQ in their infrastructure. It provided a lot of insight and guidance to our approach with understanding sort of feasibility, contracting, design, and construction. And I was curious to hear from Peter first about Redmond's approach to those elements and how you were able to set yourself up for success.
So one of the nice things about CMAQ is it's a pretty simple design. First of all, one of the things, let's step back for a second. One of the first things we did when we looked at this technology is we did some modeling and hired some engineers and consultant to look at where this technology might work and might not work, because it's not, like all things, it's not a panacea. It's going to work in certain locations and not work as well in other locations. So we wanted to make sure that the places that we were placing these facilities would give us the largest amount of lift and largest amount of change and retrofit that we could get for our dollar. So we did some modeling with Osborne Engineering helped us with it. and we're really able to identify those facilities in our watersheds that were the best candidates for this technology. So that's one thing we did. But then the second thing with the construction, it was the nice thing about it after the initial design phase, and when we went into construction, we were able to use the small public works contract and the roster through the state because we weren't going above the threshold for that. So that really helped us with the contracting, find the right contractor and narrow in on who we wanted to work with. We got 2 bids back, and really pleased with the person that we ended up, the group that we ended up hiring with for it. And relationships were mentioned. We put in 1 round of facilities, and then we had to come back and do a little more work on those facilities. And now we're putting in our 2nd round of these facilities, and all as the same pilot project in this one watershed. And we've used that same consultant 3 times. And we were able to do that because each time we were using the small public works roster.
Thanks, Peter. I heard in the previous panel about the importance of the relationships with operations and maintenance, and I think maybe Matt, do you want to speak a little bit to the approach around feasibility and design and construction, maybe incorporating some of those concepts of getting O&M on board early?
Yeah, I'm happy to try to speak to that. I think just going back to the first question again, why are we doing this? As a project manager, program manager, I always think about scope, schedule, budget, and budget is usually our limiting factor. So just acknowledging that a big push for this pilot and the way that we're going about it is trying to do a low-cost solution. We had assumptions that this would be a low-cost solution because we're doing a hardware investment in our existing infrastructure. So there's a lot of costs that we can cut out of that process, but we're still doing something new. And I think one other theme that I've heard today is just having a diverse project team, having the right people in the room, both for your technical decision making, but just for your political decision making, and acknowledging who is making those decisions. And asset management, operation, and maintenance folk are obviously a big piece of this because they're going to be the owners and operators of this infrastructure once we implement it out in the field. So their input is really critical, both to understanding the existing conditions, informing the design, but also trying to figure out how successful this investment is afterwards.
Can I add just to that too? And can't stress enough that this is a pilot project, and we're learning. So one of the things is that we built our first round of facilities, and then we found out they weren't operating how we wanted them to, just from a hardware standpoint, so we had to go back and do them again. And we learned that lesson. And hopefully we can take that lesson and pass it on to the rest of the community, pass that on to Matt and King County. But then I think Tacoma's also had questions about this, so we had a conversation with Tacoma about that. So, in those design decisions, the other thing is learn from others. And I think like any new technology, we can continue to learn how to tweak this system and how to make it work to its maximum efficiency at the lowest cost.
Thanks, Peter. Yeah, one of the things I wanted to highlight that you mentioned was kind of the adaptive nature of the technology, but I also want to stress the importance of having adaptive teams and thinking a little bit about the fact that you do inherit the infrastructure you're working with, and the moment you make assumptions about how the retrofit will go, you're already behind the 8 ball because every retrofit is different and they all have unique problems. And that was certainly something that we ran into at King County, but having a diverse set of members on the team allowed us to be a little bit more nimble and adapt to some of those challenges. So I'm wondering, throughout the process, and Matt, maybe this will be a good opportunity for you to jump in addition to maybe the challenge of every retrofit being different, whether there were other challenges that King County faced and how we kind of managed to work through those.
Thanks. Yeah, I think just reiterating your comment about adaptive teams and that we're learning through this process. So There's a little bit of a balancing act because a large team is a large cost, but you still have to have the right team in the room to be able to move forward with decision making. There's going to be some curveballs or some surprises throughout the process, and if we don't have the right stakeholders in the room, it can be very expensive to try and resolve those decisions. So just, I think, kind of acknowledging that government is here for regulation, risk management, and innovation is usually a pretty hard thing for us to push through our processes, but we made sure we had the right decision makers on the team so we could be adaptive, both with our decision making in government and in King County, but also hiring consultants that could fill the gaps that we didn't have, so the skill gaps with software and hardware. Acknowledging some of the other just real world challenges of capital delivery, stormwater retrofitting. We've inherited a legacy system. There's a lot of flaws in that system, as talked about with CSOs and sewers, and we're trying to do our best to clean up that mess, but there are real constraints to what we can and can't do. And retrofitting, just to get practical about it, one of the real hard pieces for us was putting the hardware in the existing catch basin, just making sure that there's enough room to even fit the infrastructure into our existing conditions.
And Peter, how about the City of Redmond? I know as an early adopter, you ran into a couple
Right.
of...
Well, I think it, you know, I'm an ecologist by training. I'm a stormwater geek by career. And now I'm learning to become an electrician. So yeah, and a little bit of computer scientist, just because that's the nature of the work that you needed. So, you know, there's some tinkering. So to give you examples of some of the stuff that we had to think about, we use solar panels to drive these things, but we live in the Pacific Northwest, and we were working with a company that is back east, and they didn't really understand Pacific Northwest winters. And so we had to get some more solar power juice out there. So that's the nature of one of the things that we had to consider. It's little things like that. You know, and I think moving forward, though, we're also kind of tinkering with the algorithm and also tinkering with how the system measures our outflows to make sure that we're getting the degree of information that we need and we want. But these are little tinkerings around the edges. So, for example, talking about the right team, my team consists of engineers. It also consists of outreach specialists. It also consists of monitoring specialists. One of the reasons that we picked the watershed that we did to be the watershed we're working is because we have a grant that is given through the Stormwater Action Monitoring Group, which is a group that comes together and funds monitoring actions through all the MPDS permittees in Washington pay into a fund. And Todd's very involved in this program. And then they put out money and do research. One of the research items that they funded was something called the Redmond Paired Watershed Study. And that essentially looks at actions we are taking in Redmond and comparing those actions to other watersheds to see if we're making a lift with that watershed. So basically testing our watershed restoration actions to see if they're working. So that's one of the team members that we have on board here, and that's influencing some of our decisions about how we're managing these, because this is a pilot project and might not have to be as thorough with some of our decisions in the future. But right now, we want to make sure that we are really considerate of those decisions, because we're trying to get to the understanding of the efficiencies of these programs and learn, and going through a learning process and involved in the study.
Thanks, Peter. Matt, did you have anything you wanted to add too?
Still on challenges, I believe?
Yeah.
Yeah, so just acknowledging too, because we've touched on hardware and solar power, but part of our assumption around the pilot project is trying to go for low cost. And one cost is connecting a hardwire to the existing electrical system, working within the right-of-way, working with our roads department, and working with permitting. So that was why part of our decision-making for the approach was to use solar panels. But I think we've learned through this pilot that solar panels might not be the best answer for our climate around here, because ironically, when we need our system to work the most is when it's the most cloudy, when the rain is coming. So I think in the future we could work with hardwire, but just acknowledging that some of the challenges were also just opportunities to learn something, to take this pilot into a program.
Yeah, go ahead, Peter.
Just one more thought on that too is that one of the things I also learned after putting 4 of these is I would make a decision about, okay, next time we're going to do it this way. This is the way we're going to do it, because I learned that lesson. And then only to learn that maybe something I did in that last one would have worked better on this one. So it's just every site, just, there's no hard, fast rules, I guess, is one of the things that I've learned as a challenge and a lesson learned.
Yeah. And for those of you maybe who are having difficulty tracking, because I know we didn't really cover an overview of what the retrofit does, but there are level sensors in the pond, and there's an actuated valve linked to a dashboard that uses real-time weather forecasting to open the valve or close the valve depending on anticipated rainfalls in an effort to draw down the pond and provide more capacity in a storm event. So it's a really high-level perspective of what the retrofit does, but the integration with cloud-based software actually presents a number of challenges related to contracting. Typically, we're managing construction and design contracts, but then you throw another software as a service contract on top of that, and you combine them for better or worse. It makes it really challenging because a lot of people know how to do SaaS contracts, a lot of people know how to do construction and design contracts, but when you combine them under one contract, it gets really confusing, and it can be overwhelming for procurement folks, and myself included. And I just wanted to highlight that as well, because we were trying to be efficient with the way we were doing things, but sometimes the processes that we have in place to keep these things separate are really the best practice. So really quickly here, moving on, I'm wondering if, Peter, maybe you can start by addressing the current status and evaluation of the retrofit's efficacy there.
Sure. So what we're doing right now is we are working with our contractor, Herrera, in consulting to go to do an assessment of the performance of one of the facilities we put in. So we'll be looking at that facility and be pretty much looking at the outcomes of that facility with a very specific lens, saying, were we able to flatten the hydrograph? And were we able to reduce the number of high energy, high erosive flows that were coming, high pulse counts that are coming out of that pond? So we're getting these ponds in shape so that we can have an understanding of, so we can measure those specific parameters. And then the other thing that will happen too is that we've put 4 of these in, and we'll be looking also to see in the stream itself if we can actually detect how much change we have. Well, when I say we put 4 in, we've put 2 in, and I have 2 more that are going to go online in about, hopefully, in October. So with that, and then with the additions that the 2 that King County put in the upper portions of the watershed. By the way, thank you, King County. This is an amazing partnership, and really need to thank them for doing that. It helps them with their Bear Creek watershed management goals, but also helps us. So it's a really win-win. It's a unique situation. We're really beneficial. But with all of those 6 facilities then put in and online, we'll have retrofitted, about 51% of the watershed was controlled by stormwater facilities that did not meet current standards. When we get to everything online, will be about 26% of those areas will have been retrofitted. They won't have gotten to the full current standards, but they will have been retrofitted closer to those standards. So from 51% to 26% retrofits.
Thanks, Peter. Matt, how are our ponds doing in King County?
I think they're doing pretty well. Just acknowledging the investment, the shared investment, and how we're now managing close to 50% of the watershed. And a big thank you to Redmond also for the Redmond Paired Basin Watershed Study, because we're really learning a lot about these investments and how these spot-specific capital projects are impacting the watershed level health. So we're seeing the holistic benefits of these projects, and that's a long-term 10-year study. I think we're about 7 years into it,
9.
8. So there's more years coming, but we have pre-existing conditions and then what the investments will do to help benefit the system. And really happy about the data sharing at this point. We were lucky enough to use the same software and hardware consultant, Opti, and because of that, it was really easy for Redmond and King County to share data in real time. So we're already looking over each other's shoulders and seeing the data. We can talk about next steps with the next question, but that's really valuable. I think also too, just acknowledging our folks over in operations and maintenance. We all have staff and funding constraints. I feel them a lot in capital, but feel it also in operations and maintenance. And we're currently falling short of a lot of our maintenance obligations. And I know that this innovative technology is just one more thing on top of the pile for them to deal with. But at the same time, this technology is automated for the most part. So it's really easy to pull data and show to our management and show to decision makers how much maintenance, how much time it actually takes to maintain these systems. And that's good data for us to move forward with.
Great. Thanks, Matt. And then we have a couple minutes left, but I'm really excited about our last question about sort of what a CMAQ future looks like to both of you. And Matt, you alluded to the networking of information. I wonder if maybe you want to jump in and elaborate a little bit more.
Yeah, happy to. So to reiterate, I started my career at WashDOT in the Traffic Management Center up in Shoreline, and that's where I learned a lot about intelligent transportation systems and using data and adaptive management to really control decision making in real time. And I've taken that paradigm with me over into Stormwater. And I see a lot of value, just how our ramp meters, for instance, work on I-5. We allow flow onto the freeway. We can now control flow of our stormwater. So that will allow us to adapt in real time to challenges like flooding and climate change. We were alluded to already with CSOs that we're meeting our design targets, we're developing the volume and the treatment that we think we need, but by the time those investments make it out in the field, due to climate change and other issues, we're already behind the curve with the performance that we want to have. So to really reiterate the value of this design and this approach, with typical dumb stormwater or static stormwater, you have your designed flow and then your overflow. With this new investment, we still have our overflow, but you can change your design flow at will in real time based on your conditions. And this investment is really looking at just volume right now. Volume is a water quality compliance metric for stormwater, but there's a lot of other metrics that we could also look into that are critical, fundamental for climate change. So if we start to measure things like temperature or TSS or dissolved oxygen, pH, then we can start to have decision-making frameworks for our stormwater management that isn't just flood mitigation, but is actually tied to our water quality. So for instance, when we have a summer storm, that water hits the hot asphalt, it usually goes to the stream, and that will hurt the environment. But if we had data to show us the temperature of that water, we usually have storage capacity during the summer. We're not overwhelmed. So we can just store that water underground until it's cold enough that we can then release it without detrimental impacts downstream. So just highlighting that there's a lot more data and decision points that we could factor into this framework and a lot more sites that we could implement.
Thanks, Matt. And Peter, how about you? How does CMAQ future look?
I think right now, in the short term, it's going to be about tweaking using the data that's collected. And that's one of the great things about this. We'll have data. We'll have information about how the pond's performing, because we don't have that right now. So taking that information, that's a short term. And then in the long term, what I see is a couple things. One, we might find that over time, we don't need systems to be as fancy as they are now. They might not have to be continuous monitoring. Maybe it's staged monitoring, where it gets to a certain stage and we're able to do staged releases. Maybe that's something that will help us drive some efficiencies and cost savings and things. The other thing I'm hopeful to see too is that maybe there's going to be some competition in the marketplace for this, and then that competition will drive innovation. It will drive, more tools, different people doing it. So I'm looking forward to that. So those are a couple of things that we're thinking about. But one of the other things that we're thinking about that's very exciting, and Matt alluded to this, is wiring watersheds so that the ponds are all connected. And so you're not managing individual ponds. You're managing the watershed as a whole. And maybe rather than having one big watershed, you're looking at all of these facilities as a regional asset and then managing them as a regional asset. So one pond's holding water, another's releasing. So those are some of the things, some of the questions that we are kind of concerned. I can also say too, you alluded to the fact that we kind of glossed over how this system works, but we'll be outside, and if you want to talk about more of the specifics, we'll get in the nitty-gritty of that. We didn't want to do that here.
Great. Thanks, Peter. Did you have anything else you wanted to add, Matt?
Yeah, one thing that I wanted to touch on too was just the paradigm shift from modeling to monitoring. So in stormwater, we do a lot of H&H modeling. It takes a lot of time, usually an engineer's time, to understand the existing conditions, to factor in things like the existing conveyance, the impervious area, the land use, what have you, and we put that into a model, and we get some data out, and we try to calibrate that model to existing conditions with what we've observed. But really, that's a long, expensive effort for maybe not the right answer, because we're not fully aware of what's happening out in the environment. But there's also an investment cost for this type of hardware, but once you have that hardware out in the system, now we're monitoring the real effects in real time. So it doesn't really matter what we don't know, but we're seeing how the system is functioning in real time, and that data is now really valuable, and just highlighting how the investment cost, or the cost to access that data once we've made the investment, is very low. So data accessibility, data transparency, using this data to not just inform the operation of the assets, but also request resources for future projects and showing how our existing system is doing. It's one of my opinions that one of the reasons why traffic or DOT work is so well funded is because it's well understood or experienced by the public. We all drive through traffic, and we also have things like the traffic map. Pretty easy to follow that green is good and red is bad. But if we had a map like that that also showed stormwater concepts to the public, now we have a lot wider audience that better understands our challenges and our needs and the resources to help fix some of these problems, and more solutions that will help our community.
Thanks, everybody.